Okay, let's run through another question together. So we're going to do another one on electromagnetic induction. We're going to now calculate the induced EMF. So there's a revision PowerPoint you can go back through, and there's other videos on electromagnetic induction. Let's just do a question in this one, and then I'll leave you with a revision slide at the end, which you can scan through yourself to recap. Okay, so what have we got? Let's analyse this question and read it out together. And as we usually do, let's underline stuff as we go. So a conductor of 0.5 meters length is moved at 30 meters per second, okay, perpendicularly, which means what? Which means at 90 degrees, at a right angle, through a magnetic field of flux density 3 Tesla. And we want to be calculating the induced EMF. Right, okay. So what formula do we know? Let's just get this out of the way. So what formula do we know that includes all of these things? Length, velocity, and we're asked for the induced EMF, and we've been given the flux density. Well, here's the one that we know. The induced EMF is equal to the flux density of the magnetic field multiplied by the length of the conductor multiplied by the velocity that the conductor is being passed through the field. Right, okay. So let's see if we can just check our values. 0.5 meters. Meters is a base value for length. Perfect. 30 meters per second, which is the velocity the conductor is traveling through the field. Meters is the base unit. Perfect. No problem. And we're going perpendicularly at a right angle. Doesn't make a difference to this. I'm just making you aware of that. And then the flux density of the magnetic field is 3 Tesla. Right, let's punch some values in and get this done. So the induced EMF is equal to 3 Tesla multiplied by the length of the conductor, which is 0.5 meters, multiplied by the velocity, which it's traveling through, which is 30 meters per second. Okay. So when we punch this into our calculators, we're going to be given a value of 45 volts. Okay, so why are we writing volts? Because we know that EMF is measured in volts, don't we? And real quick one on the side here, if you're looking for a way to remember this, here we go, look, the force, if you're wondering what EMF is, that moves electrons. Yeah? Good way to remember that in the future. Okay, let's cut this off and do what we usually do here. Let's transpose this formula now, because what if another question came along that was asking us for the velocity? If we've been given the length, given the flux density, given the induced EMF, and it's asking us what's the velocity, let's do it over here. Let's transpose it. So if we want to make V the subject of this formula. So the induced EMF is equal to the flux density of the magnetic field multiplied by the length multiplied by the velocity. But we want V on its own for velocity. So remember, as we did last time, we could grab these two as a chunk and move them or cancel them out. So currently we're multiplying by these two as a chunk together. So let's divide by them together. So flux density by length. And then let's do the same on this side. So we're going to divide by the flux density by the length. Okay, that's going to give us this now, isn't it? It's going to give us the induced EMF divided by the flux density multiplied by length is equal to the velocity. And then we do what we usually do, flip it around so we look smart. Velocity is equal to the induced EMF divided by the flux density multiplied by length. Let's quickly recap. So we read through the question, we analyse our values that were given, don't we? And then we think of the formula that's best suited to this. In this case, we've been asked for the induced EMF. We're looking at the values there. We know it's this one. So the induced EMF is equal to the magnetic flux density of the field multiplied by the length multiplied by the velocity. Put our values in, get our answer, make sure the unit we use is correct. Because you may be given other answers in an exam, which might be 45 amps as well as one of your options. Obviously choose the correct one. And then up here, so we transposed the formula, didn't we? Because we know that sometimes we're going to be asked for other things, like we might be asked for length, or we might be asked for velocity when we've got the other values. So we need to transpose it, which we've done here. There's the original formula. We can move stuff as little chunks like we've done here. And reverse back into this video if you want to go over that again, it's fine. And then this was a good bit down here. So EMF is measured in volts, we know this. And a good way to remember that, if you do this backwards, is the force that moves electrons. Because that's how we define EMF, isn't it? The force that moves electrons. And we are going to move on. I'm going to leave you with this revision page on this subject, which will be helpful for you to go through. And I'll just stop talking and I'll click the slides through for you.